Just like structures in C++, a class is also a user-defined data type. In order to create a class, we need to write the keyword class and then the name of the class. For this code, I will create a very simple class with name A. After the name of the class, we need to insert the body of the class. The body of the class starts with a left curly bracket and ends at a right curly bracket. And after that, a semicolon is inserted. This complete block is called the class definition. And inside the class definition, the class members are declared or defined. The class members consist of data members and member functions. Here I will use a data member X of data type int and another data member Y of data type int. After some time, I will also add member functions to this definition as well. These two data members are currently uninitialized. We can do the default initialization, and after that, we can also do member by member initialization as well. In my previous videos related to structures, I discussed how structures are initialized. This complete block is called the definition of class. These are the data members of the class. The class definition will act as a blueprint and no memory is allocated. The memory is only allocated when the objects of the class are created. Now,
The same rule
here I
applies to
have
classes
created
as
this
well.
class at a global level and it is visible inside main. We can create this class inside main as well. Let's create an object of this class inside main. In order to create an object of the class, you first need to write the name of the class and then the name of its variable, a space a1. Now I have created an object a1 of class A. In simple words, we can say that this is our data type A and this is the name of the variable of our data type. And in technical terms or in terms of object oriented programming, we say that this is a class and this is the object of class. So the class is in fact our data type and the object is in fact the variable of that data type. So class and object. Now, if you want to access the data member by directly writing its name, then the compiler will generate an error that this variable has not been declared here or at the global level. So the compiler will not execute this line of code. In order to access the data member of a class, you need to first write the name of the object and then a dot operator and then the name of the member. So here I have written this is my object, this is the dot operator also called as member access operator, and this is the member. So in this way, the data member can be accessed only by using the member access operator. Now, when we try to execute this code, then the compiler will again generate an error that this member is private and cannot be accessed outside of class. Now, what is the private and public data members? There are different access modes of data members. The access modes are private, public, and protected. A private data member is only accessible inside the class. A public data member is accessible inside the class and outside the class as well. A protected data member is accessible inside the class. Protected data member is accessible inside the base class and inside child classes and not accessible outside of base class. What is base and child classes? I will explain it in my later lectures. So now in order to declare these members as private, public, or protected, we need to write a line of code that is called member access specifier. When we have not inserted here any line, then the compiler has automatically declared these members as private. So currently these members are private. This line of code, this line of code is called member access specifier. Member access specifier or simple access specifier. Now, when the member access specifier is not mentioned here, then by default the member access specifier is private. And when the member access specifier is private, then all the data members that are declared after the member access specifier, all those data members will be declared as private. So private data members can only be accessed inside the definition of class and cannot be accessed outside of the class. So that's why when we try to execute this instruction, the compiler will generate an error that X is a private member of class A and it cannot be accessed outside of me. So now let's try to change the member access specifier and use a public member access specifier here. Now I have written here public. Now this member access specifier has made these two variables or data members public. These data members can be accessed outside of the class as well, in addition to be accessible inside the class. Now let's execute the code and see the result. When this line of code is executed, then an object is created inside memory. Memory is allocated to store the contents of object, and the object consists of two data members, X and Y, and their values are uninitialized, or we can say that they hold the garbage value. What is the size of the object? The size of the object is 8 bytes. For each object, the compiler will allocate 8 bytes of memory. And how these bytes are allocated, I have already discussed in my previous lecture related to how structures are stored in memory. The same rule applies to classes as well. After that, when this instruction is executed, then a1.x holds the value of 10. So 10 is stored in x. X will become equal to 10. Now, if you write another instruction after that, a1.y equals to 20, and when this is executed, then y will hold the value of 20. Let's execute and see the result. So the code is executed without any error, and memory has been allocated, and the values have been stored. Now let's try to change the access mode of y. If I write private here, then the member y will become private. Now the compiler will generate an error when this instruction is executed. Compiler will not execute the code and will generate an error that y is private. Y is private. If you want to access y outside of the main, you need to write public here. Let's write public after private. Now y is accessible because after this access specifier, we have written or declared y here. I am just trying to elaborate the concept that public and private can be written anywhere inside the definition of class, and all the instructions that you are using to declare members after any access specifier statement. Those members will be declared private or public according to the member access specifier that was written before the instruction. Now, if you declare any member here, then that member will be declared as private. So in this way, private or public, anywhere inside code. And when this code is executed, now y has also been declared as public. The code will be executed without any error. Now this line will be executed without any error. And if
You
you
can
want, you
write
may skip the line from this one. If you write another statement, and if you want to write private here, then after private, we have not written any variable or member. So still these two members are public. And this code will be executed without any error because we have written public before the declaration of these two members. So now let's execute and see the result. So the code is executing without any error. Now let's remove this statement and this statement as well. And let's display the value of these two members at the output. Cout a1 dot y and l cout a1 dot x and l. Now the program will display the value of y and then the value of x of a1. And the output will be 20, and in the next line 10 will be displayed. So 20 and 10, the program has displayed the values. Now let's create another object, a2. Now in this line of code, I have created two objects of class a1 and a2. Separate memory spaces will be allocated for these objects. Now when this instruction is executed, then a1 will be created in memory with variables or members x and y. Both will hold the garbage values, and a2 will be created in memory with variables x, y. Both will hold the garbage values because we have not initialized there. Now, if member x of a1 is initialized to 50, member a1 of y is initialized to 20, a2 dot x is initialized to 12, a2 dot y is initialized to 34. As a result of the execution of this instruction, 50 will be stored in x of a1. And when this instruction is executed, then 20 will be stored in y of a1. This is stored here instead of the previous garbage value. Now, when this instruction is executed, then 12 will be stored in x, and when this instruction is executed, then 34 will be stored in y of a2. So 34. Now let's try to display the data. Let's display all the members. a1 dot y and l cout a2 dot y and l cout a2 dot y and l. Here a2 dot x. Now when this line is executed, then 50 will be displayed. Then for this line, 20 will be displayed. For this line, 12 will be displayed. And for this line, 34 will be displayed. So 50, 20, 12, 34. Now let's try to add a member function inside the definition of class, which will be used to display the values of the members of the class. Let's add a member function to display the values instead of using instruction to display the value individually for each member. In order to add a member function, you first need to write the return type. Here, void shows that the function will not return any value, then the name of the function, then the parameters, and then the body of the function. Here, I will write the complete definition of the function inside the definition of class. You may write only declaration here and definition outside of class. So first, let's create the code inside the body of the function to display the value of the members of the class. Cout x equals to x, cout y equals to y. The access mode or member access specifier for these two data members is public, and void show is also public because we have mentioned only a single access specifier mode here before all these members. When x and y both are public, then they are accessible inside the definition of class and outside the definition as well. When you are writing a definition of the member function of a class, you can access the data members directly inside the definition of the function without using the name of the object and dot operator or name of the class. So here we can access the data members directly by using only their names. If the data members are declared private, even then the data members are accessible inside the definition of class and inside the definitions of functions that are members of class. Now, in order to use the show function here, we again need to access the function show by using an object name and then the dot operator. Now, when this line of code is executed, when show is also a member of class, then the compiler will create an object A1 inside memory, an object A2 inside memory with garbage values, and will allocate space to store the members of A1, data members of A1 and data members of A2. For member functions, only a single memory space is allocated that will hold the definition of the member function, and that memory space will be shared with both the objects. So this member function is only stored inside a single memory space. For each object, only a single copy of the member function is stored. Not separate spaces are allocated for each copy of the object. Now the objects can access this member function from the memory. When these all instructions are executed, then the values are stored in the member variables. Let's try to access the member function show to display the value of object A1. When you want to access the show of A1, you need to write A1 dot show. When this line of code is executed, then from this line of code, the compiler will move to the definition of the function, which is stored in memory. And in the definition, it will display x equals to at the output, x equals to, and then the value of x of a1 is displayed. So value of x of a1 will be displayed, and 50 will be displayed here. And end L will bring the cursor to the start of the next line. This is end L. After that, when the next instruction is executed, y will be displayed equal to, and then for y, the value of the member y of a1 will be displayed. So 20 will be displayed, and end L will bring the cursor to the start of the next line. After that, let's insert another instruction to access the member show of object a2 dot show. After the complete execution of this instruction, control will be returned to the next instruction. Now when this instruction is executed, again the control will be transferred to the definition of function that is stored in memory space, and now inside the definition x equals to will be displayed at the output. After that, the value of x of a2 will be displayed 12, and L will bring the cursor to the start of the next line. And when this next instruction is executed, y equals to will be displayed, and then the value of y of a2 will be displayed, and 34 will be displayed, and L will bring the cursor to the start of the next line, and this bracket will move the sequence of execution to the next line. So in this way, the program will be executed, and for all the objects of classes, separate spaces are allocated. Only a same memory space is allocated to store all the definitions of the function members of the class for all the objects. Now let's execute the code and see the result. So the code is displaying the proper values. Now if you change the member access specifier to private, then x will become private, y will become private, show will become private, and these x, y, and show cannot be accessed outside of class. Now let's try to change the member access specifier of the function show to public. Here I have changed the member access specifier for function member of the class to public. Now this is the member function of class. These are the data members of the class. And this is the definition of class. And these are the member access specifiers. For data members, the member access specifier is private, and for member function, their member access is public. Data members can be accessed inside the definition of the class and inside this function as well without using the name of the object or class. And this function member is accessible inside the class and also outside of the class as well. In object-oriented programming, the data members of a class are called attributes, and member functions of a class are called methods. Here we have only a single member function, So I will call it as method. Now, when this code is executed, then the compiler will generate an error for this instruction, for this instruction, for this instruction, and for this instruction because X and Y members are private. And these two instructions will be executed without any error. So we need to remove these instructions in order to execute the code without any error. Now the code will be executed without any error because now we are accessing only the public member outside of class. But the X and Y members are uninitialized, and the program will display the garbage value of these two members for each object. So first, X and Y of object A1 will be displayed, and then X and Y of object A2 will be displayed. The compiler is displaying garbage values for all these data members for the specific objects. If you want to initialize these data members by using a default value, let's initialize X to 1 and Y to 2. This is called the default initialization method. And when this method is used when an object A1 is created, then the data members of object A1 will be initialized with values 1 and 2. And similarly for A2, the data members will be initialized to 1 and 2 as well. The program will display the default values of the data members. So the program is now showing x equals to 1, y equals to 2, x equals to 1, y equals to 2. So in this way, we can access the private members by using a public member function. Now, if you make this member function private as well, then this member function will not be accessible outside of class as well. Let's add another member function to initialize these members with with some values, and let's name that function as init initialization, and inside the parameter I will use a variable a of data type int and variable b of data type int as well. And inside the body I will write x equals to a and y equals to b. When this function is created, then the access mode for this function is public, and the body of this function will initialize x to a and y to b, and during function call we will pass the values for a and b in this function. Now let's use this function init to initialize the values for a1. I need to write a1, then dot operator, then the name of the function, and then I will pass values. So I will pass 5, 6. Now when this code is executed, then two objects will be created inside memory, and a1 x y with default values 1 and 2, and a2 will be created in memory x equals to 1, y equals to 2, and two members functions will be stored in memory for these objects in separate memory spaces. When this instruction is executed, then the program sequence is moved to the definition of init function, and 5 is assigned to A, 6 is assigned to B, and inside the body, X of A1 will be accessed and Y of A1 will be accessed. So X will be assigned 5 and Y will be assigned 6. X will be assigned 5, Y will be assigned 6. And after that, the program will return to the execution of the next instruction. In next instruction, A1 show will be called, and inside the body, X and Y of A1 will be accessed and their values will be displayed. And after that, the program will return to the next line. And again, in next line, show for A2 will be called, and X and Y of A2 will be displayed. And after that, the program will return to the next execution of instruction. So X equals to 5, Y equals to 6, X equals to 1, Y equals to 2. So in this way, we can create a class with data members and member functions. We can set the modes of the data members and member functions, and we can access those data members and member functions by using the names of the objects with dot operator. Let's create another class with name box. The box class has private data members or attributes, length of data type double, width of data type double, height of data type double. I will add some methods, public methods or public functions of class box are voids space set to set the values of length, width, and height, double space L, double space W, double space H. These are the three parameters that will be passed to this function set. And inside the body, I will assign L to length of the box, width is assigned the value of W, and height is assigned H. Now let's add another public method with name void space calculate volume. This is a function to calculate the volume of the box, and inside the definition, I will display cout volume equals to length into width into height. So this is my total class definition that consists of three attributes. These attributes are private and two public methods. One public method is used to set the dimensions of box, and the next method is used to display the volume of the box. Inside main, let's create two objects of class box. Box space box1. This is my first object, comma box2. This is my second object. So in this line, I have created two objects of class box. Let's set the dimensions of box1 by calling the function set. Here I will set the dimensions to 2.5, comma 3.5, comma 4.5. And another function, box1 dot calculate volume, to display the volume of box1. Then for box2, I will use again the set function and will pass the dimensions 4, 5, comma 6.6. And then box2 calculate volume to display the volume of box2. Now when this line of code is executed, then box1 is created inside memory or memory space is allocated for box 1, and box 1 has data members or attributes of length, width, and height. When this box is created, these attributes will have garbage values stored in them. And this box 1 has also got methods set and calculate volume. These are the methods. Another box 2 is created length, width, height. Garbage will be stored in all these members or attributes. And this box 2 has the same method set and calculate volume. So a memory space will be allocated to store only one copy of calculate volume and one copy of set, and these copies will be used by both of these boxes. So then the set function of box 1 is called, and 2.5 is passed to L, then 3.5 is passed to W, and 4.5 is passed to H, and length is 2.5, 3.5, 4.5, and this is the length, width, height of box 1. So box 1 length will be assigned a value of 2.5, and 2.5 will be stored in memory, and then 3.5 will be stored for width, and for height 4.5. So all these members or attributes of box 1 will be assigned these values. After the function returns, the next instruction is executed, and when this function is called, again the function is called for box 1, and inside the body of the function, the length, width, and height of box 1 is used to calculate the volume. And volume equals to the multiple of these three variables will be displayed at the output. After that, when this function returns, then the next function for box 2 set is called, and again the program moves to this set. 4 is assigned to length, then 5 is assigned to width, and 6.6 is assigned to edge, and the length of box 2 is assigned a value of 4, and then width is assigned 5, and then height is assigned 6.6 for box 2. So here 4, 5, 6.6 will be stored. And when this function returns, then the next instruction is executed, and box 2 dot calculate volume will be executed. Box 2 dot calculate volume moves the sequence of execution to the definition of the function calculate volume, and for box 2 the calculate volume function is called, and it will display the volume by calculating the multiple of length, width, height, and will display the result. And after that, the program will be terminated. So in this way, two box objects are stored in separate memory spaces, and both box objects have different values for its data members. Now let's execute the code and see the out. So volume 39.375, this is the volume of box 1, and volume equals to 132, this is the volume for box 2. In the similar way, many different types of classes with different attributes and different methods can be created. Similarly, the constructors and destructors can also be added to the class definition as well. I will explain all these concepts one by one in my later lectures.